Hello everyone and welcome to today's lesson. We are going to focus on interpolation today, and we will first discuss what is interpolation, and then we will focus on how to do it. So if you haven't tuned into my channel before, I want to welcome you. My name is Andres and I'm the founder of the Excel Math Doctor, and I want to walk this journey with you to grow you to become an A+ high school student. So if you are a high school student, guys, please go and subscribe on my channel. This is for you if you are in America, whether you are in Brazil or in Europe or anywhere in the world. I want to walk this journey with you, and I want to help you and grow you and nurture you to become an A+ student and realize the full potential of all the talent that is within you. All right, let's get started. All right, so let's define firstly what is interpolation. Interpolation is basically the process of establishing an unknown data point between a fixed set of data points. So what does that mean? All right, so firstly, I'm going to show you guys a table here of temperature versus density. All right, so this is the properties of water, and this is the data set that we are going to use to discuss firstly and define interpolation and how to do interpolation. So as you can see, we have a different set of temperatures for a given set of density. All right, so suppose, and this is a very common thing that you will use in life, whether you're on school or even after school. So suppose you want to know the temperature at a value that's not tabulated. So as you can see here, we have temperature of 10 degrees, 30 degrees, and then at 50 and 70, and that was part of the standard data set. But suppose you want to know what is the density of water at a temperature other than the standard values in the table. So in this case, we are going to work out and define what is the density at a temperature of 48 degrees. All right, guys. Now, as you can see here, right, this is a bit different than normal, right? If that temperature was at 40 degrees, basic rule of thumb, you can then just go and add the density at 30 degrees and at 50 degrees, do the arithmetic sum of those and divide it by 2. And then you can get the average density between those two values. However, we are now at a non-standard temperature at 48. So the question is, what is that density? All right, and this is where the process of interpolation comes into play. So interpolation means we want to determine the value of a certain data point. We want to get the full numeric value of a certain data point, which is in the middle of a few surrounding data points. And that surrounding data points give us the trend or the curve and allows us then to determine this data point, which is in the middle. So one thing to note here is that temperature increases in this table, right, from top to the bottom. However, density decreases from top to bottom, so it increases in the opposite direction. All right, the first things that you have to realize and the key points that you need to take account of is firstly to know and understand your data. So actually, before you start to interpolate and determine a specific numeric value of your data, you need to know what you are working with. All right, you need to have a sound knowledge of the specific data that you're working with, and you need to know the characteristics of it. Also, what is very important is to visualize your data. Always try and visualize, and this is a very common mathematics principle. And if you want to exceed in math, always try and visualize it in your mind, right? You need to see how these data points add up. You need to try and see the trend in your mind, and that will help you a lot. So what do I mean by that? Well, firstly, you need to know, does your data behave in a type of a polynomial effect, whether a power curve or a quadratic curve? You need to know, if I increase the one data point in the x-axis, how will it react in the y-axis? All right, will it follow possibly a straight line relationship, as is shown in the sketch here? Or will it follow a polynomial with a third degree type of trend? All right, or will it follow a type of an inverse relationship? All right, you need to understand what you want to do. So in this case, with our temperature and density, this is a classic example where we actually will follow this type of curve, right? So it's more towards an inverse type of parabolic relationship. All right, so a few important considerations. Let's consider direct proportionality, right? So I'm going to show you just this curve. So direct proportionality, if we say x is directly proportional to y, that is almost saying, like, if you have a business and you do sales, in the x-axis you can have, the quantity of sales, and in the y-axis is your revenue. The more you sell, the more is your revenue or your income. All right, so this is direct proportionality. So and if we want to interpolate there's our yellow data point, which is between the outer parts. All right, and then here is just, direct proportionality can also be the inverse. So if we have a negative gradient, we can also, that's also under the same category. Then we also get, proportionalities which are more quadratic proportionalities. So for example, x is directly proportional to y squared, as in this example. And what we just need to know is, suppose I want to join or determine a data points between the blue on this point and between the blue on this side. If I want to establish a linear relationship between those 2 points, you need to know that you will have an error, right? You will have a certain area which is described by this yellow arrow here, and the error comes from the fact that the nature of the data or the nature of the curve is that you have this quadratic relationship, but you want to establish a data point between those two, all right, utilizing a straight line. And because of that, the difference that you have here, which is indicated by this yellow arrow, that will be your error if you were to approximate it with a linear curve. And we'll get to that just now. And then lastly as well, here's just an example where you have y is directly proportional to x squared, which is a typical parabola, right? So you can use linear interpolation if you need a quick answer. Okay, always remember that. Typically when it gets to exams, that's a very common thing to do, but just know that it might not be that accurate, right? If we have a direct proportional relationship, or in other words, we have just a straight line. All right, we have a straight line, as in this first little sketch here. So if you have a straight line of data and you can plot all those data points on a straight line, linear interpolation is your best bet. It's accurate, and that is the way to go. But just know that if you have data such as this, where you have any parabolic relationships, you can get an error, right? You can get a small little bit of an error in that. It might not be that accurate, but worst case scenario, you might be about 80% accurate. Okay, let's go to the next phase to focus on the how. All right, so the perfect way to do actually interpolation is to plot your data points and to try and add a trend line or curve to this data, and then to read it off the graph. That is the best way. All right, so, and that's the most accurate way. So let's suppose we just plot these data points. So look at this sketch here. So we have here the water density versus temperature, and here you can see all the points that are plotted. So the most accurate way is, let us just determine an equation from the data points. All right, so firstly, let's suppose I take a straight line relationship in this instance. Okay, and now as discussed previously, if you have a direct proportionality with a quadratic function in it, so for example, in x is directly proportional to y squared and so forth, if you want to add a straight line, you'll get an error factor, and this is what we see here. So just look at this. If you want to add a straight line to this data, you can see that none of the data points is on the line, and that is because a straight line is not really the relationship in a temperature versus density property of water. However, if you were to add a parabolic line to this, so a quadratic equation, you can see that almost all of the data points fit on this curve. So in reality, guys, if you want to plot a curve of this, you want to make a graph of this, as in this picture here, all you can do is, if you want to get any value, right, that is in between the data points that was plotted, you can just physically go and look at the y value and look at the x value and go and read it off. You can go and read it off any value that you want, all right, and then you can get an exact approximation. However, the thing is, in real life scenario, you don't always have the time to do this. You don't always have the time to go and plot this. And that is where we get to, interpolation option number 2. All right, and this is to make a quick visual sketch of the data. So all you need to do is, so getting back to our table, we are at the temperature of 48 degrees and the density is the unknown. So I'm making this density the algebraic variable y. All right, so for us to do interpolation or linear interpolation in this instance, I want to plot the adjacent data points to this specific unknown data point, right? So that means I need to plot the point of 50 degrees and 988 kilogram per cubic meter, as well as the data point of 30 degrees Celsius and 996 kilogram per cubic meter, which means that our data point, which we don't know, is actually in between. All right, so we plotted this now in the Cartesian plane, all right? And now what's easy about this, we can just apply, normal geometric relations to solve the unknown. All right, guys, so let's look at this, and this is a very smart way to do and analyze this. Effectively, if we look at the straight line relationship, all right, this is none other than a triangle in the Cartesian plane. All right, so we have, our outer data points form actually the big triangle here, and then where our yellow data point is, that forms the smaller triangle. So what's cool about this is you actually have a common angle between these two. You have both of these triangles here have 90-degree angles. They have also a common angle, as well as one of the sides in each are parallel to each other. So that means in effect that all the sides are proportional to one another. That means if you were to take the ratio of each of the corresponding sides in these triangles, the ratio of all of them will be equal in proportionality. So for example, if you were to take this short side of the small triangle and divide it by the long side of that triangle, and then also one of the parallel sides of the small triangle and divide that by the big side of the bigger triangle, that would be an equal relationship, an equal proportionality. So all we can do now is, let us just break it down into, unknowns, algebraic variables, and we can call the y distance, so from our data point y, which we need to calculate, towards the bottom side here, we can call that a. The opposing side we will call b, all right? And then of the small triangle, this side that is parallel to the x-axis we'll call c, and then the long one down here we'll call d. And now we can just set up a simple equation to say a divided by b. All right, so a divided by b is equal to c divided by d. And we can say this because these are two angles that are proportional to one another. All right, and then we just substitute in our numbers and specific values. So we can say y minus 996 divided by 988 minus 996 equals 48 minus 30 divided by 50 minus 30. And all I'm doing, guys, I'm just substituting the data points that we have here in this specific values. Now you might have here a question to ask me, right, but the value of 988 is actually lower than 996, and I plotted my curve upwards. Well, that is correct. However, if you were to look at this first portion of the equation, if I just minus the top and bottom, the numerator and denominator with -1, then this same equation and the way I plotted it will be directly equal if I were to have plotted it in the correct direction to go downward. Okay, and then I can just solve the value of y, and that brings me to that the unknown value of y, so the density of water at 48 degrees is a value of 988.8 kilogram per cubic meters. Alright guys, that brings us to the end of today's lesson. I hope you enjoyed this, and thank you very much for watching. Hello everyone, I just want to remind you as well that we do have a mathematics assignment help service. So in the description box below, go and follow the link and upload your mathematics assignment and we will work on it for you. Thank you, bye bye.